Okay, so 11.2 is called simplifying radical expressions. Okay, so really this is kind of an extension of what we just did in 11.1 with simplifying radical expressions and rational exponents. Okay, so we're still working with the same stuff. We're just working with a few more details. Okay, so let's start with these three things right here. Okay. This was on the warm-up today, so I'm assuming that this is familiar, or at least this is not the first time you've seen this. Okay. If you have two numbers that have the same base, okay, with different exponents, we add the exponents. Okay. If you have a power to a power, you multiply them. And if you have a fraction that has a exponent, you just do that exponent to the top and to the bottom. That should not be new information. Is that fair assessment? True? Check. So you might write down at least the top two because that is often forgotten. People forget when you're supposed to multiply and when you're supposed to add. So you might give yourself a little example so you don't forget. So I'm going to slide this over. I'll go back here in a second. Okay. So did I give you guys enough time to finish that? Sorry. I got set of waiting, impatient. Okay, so here's going to be our first couple examples. How many do we have? 5 examples. Okay, so we'll start with question number 1. Okay, so they're basically kind of blanket statementing these and giving us the A is going to be 64, the B is going to be 4, the M is a third, and N is 3/2. Okay, so for question number 1, what is the first thing that I want to do given a to the nth times a to the nth? Okay, so the first thing we want to do is plug in the values, right? We always want to substitute in the values that we know. So we would start by saying that this is going to be 64 to the 1/3 times 64 to the 3/2. Okay, so now how would I go about simplifying that? Okay, so they do have the same base, so we need to add the exponents. And in doing that, we are going to need a common denominator, right? Okay, so I'll just do a little side work. If I have 2/3 plus 3/2, what would my common denominator have to be? 6. So can we all agree that that would be 2/6 plus 9/6? Okay, so back on my red equation, my new exponent is going to be 64 to the 11/6. Good. Okay, now can I simplify this? Okay, so we're thinking the 6th root of 64, 6th root of 64, which Faith said was 2. And she must know what 2 to the 11th power is also. Okay, you can use a calculator for that part. I don't know what it is either. $1,000 and what? Oh, 2,000. 2,048. Did you do that in your head? Yeah. Wow. Tyler, well done. Mental math genius. Okay, so now we're working on number 2. We have a times b to the n. So what's the first thing I'm going to do? Plug in our numbers. So we have 64 times 4 to the, what was n again? Oh yeah, 3 halves. Okay, now how would I do this one? There's actually 2 different ways I can go about doing this. Exactly. Okay, so I can start by multiplying 64 times 4, because everybody knows what that is. Maybe not. Or you can distribute the 3 halves. Maybe we should do the ones we can do without a calculator. Let's try it. So let's do 64 to the 3 halves times 4 to the 3 halves. Let's see if we can do this without a calculator. So for 64 to the 3 halves, we have a square root of 64, which is 8. So we have 8 to the 3rd, which we'll do here in a second. And then we have 4 to the 3 halves, so that's the square root of 4. 2, so we have 2/3. So anybody know what 8 cubed is? Come on, Tyler, you know this. 512? 512. Ooh, we know what 2 cubed is. 8. So therefore, 512 times 8 is 4096. Nice. Good. Okay. So number 3, we have a to the m to the n. A to the m to the n to the n. Sorry. So we got 64 to the, what was m again? 1/3. To the 3 halves. Okay, so how do we go about simplifying this one?
Multiply the exponents.
Good, multiply the exponent. So what is 1/3 times 3 halves? 3/6, which reduces to 1/2, nice. And the square root of 64 makes 8, nice. That was a good one. I like the ones we don't need calculators for. I feel a lot smarter that way. All right, so this one is a to the n. So we got 64 to the 3 halves over 64 to the m, which is 1/3. Okay, how would I do number 4? You guys read that all right? Let me know if I ever need to zoom in. Sometimes I forget about that. Does anybody know this one? This is one we probably haven't quite talked about yet. It is, good. So when we have division with the same base, we're going to subtract the exponents. Good. So we're going to have kind of side work over here. We have 3 halves minus 1/3. So again, we need a common denominator. What would my common denominator be? So we would have 9/6 minus 2/6. Anybody else agree that that makes 7/6? So that would give us 64 to the 7/6. And the 6th root of 64, we're getting this now, is 2. And so 2 to the 7th power is whatever 64 times 2 is. 128. Nice. Look at that, you guys. We don't need calculators, except for on those first 2. Okay. All right, so now we have a over b. So this one's going to be 64 over 4, and then n to the n, so 3 halves. So how would I do this one? Okay, 2 ways to do this one. Wow. Same thing like number 2 up there. We have parentheses that we can simplify. So we could do 64 divided by 4, and then do the 3 halves. Or we could do 64 to 3 halves over 4 to 3 halves. So you want to divide by 4. So what's 64 divided by 4? So 16 to the 3 halves. So that gives me the square root of 16. 4 to the 3rd. 64. Nice. Feel pretty good about that? You're right there, Brady. All right. He starts coughing too much. Let's see. Let's do these ones. Okay, so this is what I'm going to have you do. In your notes, you guys try number 3. Okay, so I'll give you a second, see if you can get question number 3 correct, and we'll see if you get it right. Okay, so here's, I can make it bigger. Oh, you found it? So it says the quantity of 12 to the 2/3 times 12 to the 4/3, end parenthesis, to the 3/2. So we've got powers to the powers here, which sounds pretty godly. So try to do it without a calculator if you can. You might need one at the end. Just maybe. I don't think I would know the last one. Whatever that is. So the nice thing is when you get to like AP Calculus, you can leave your answer as 12 to the 3rd. And you don't have to actually get to the final answer. Okay, everybody done? So the first thing everybody did was distribute the exponent through, right, and multiply? Oh, but could you do that? Technically, you could have done that, so that wouldn't have been wrong to do. I wouldn't have done that either. I would have immediately added the exponents on the inside. Right, good point. I can't disagree with that. So we go, let's see, we have 6/3. Would we all agree that 6/3 makes 2? And then we have to the 3/2, and now we can multiply those exponents. So 2 times 3/2 makes 6/2, which reduces to 3. So anybody know what 12 to the 3rd power is? 17/20. And you knew that off the top of your head, right? Absolutely. Good. All right, let's see if you can do this one. Whoa, sorry. Where am I going? Sliding across the screen. How about that one? Okay, try number 4 here. Okay, you ready? I think you can do this one without a calculator. Okay, so where did you start? What did you do first? Okay, good. Distribute the 2. So did everybody say that 6 squared is 36? Sorry, that was the radio. And for my x, I have 1/3 times 2. So what's my x exponent on top? 2/3, good. Okay, the bottom is untouched as of yet. Okay, so now, sorry, that's a 5/3. Oops. 5/3. Okay, so now what am I going to do? What's that? Okay, good. So the x's, we're going to subtract. Ooh, and we can do that. 2/3 minus 5/3. What's 2/3 minus 5/3? Ooh, so negative 3/3, which is 1. Now, can I leave it like that? You cannot have a negative exponent, so what are we going to do with the x? Put it in the bottom. Very good. So how many people got 36 over xy as an answer? No? But at least you found your mistake? Okay, good. Okay, so we're good there? All right, let's work with radicals. Let's see, I want to see if they have a good, oh yeah, let's do this. Yeah, I want to go back up and steal this one, sorry. I like this one good, it's a good one. Copy. Okay, so what number am I on, like 5? Sure, okay, 5. Question number 5. Okay, so now we are working within radical form, okay? So here is going to be kind of a blanket statement for working with radicals. Are you ready? Okay, when you're multiplying radicals together, you can multiply numbers that are on the outside together, and you can multiply numbers that are on the inside together only if they're the same kind of radical. Okay, which means you can't multiply square root pieces together with cube root pieces. Okay, so in this scenario, what things are on the outside? X. So x, there's nothing else to multiply by, so there's just an x on the outside. Okay, now on the inside, we're going to multiply all the stuff on the inside together. So what can we multiply? 2 and 4, which makes 8. What else? And we can multiply the y. So I'm going to write the x first because that's alphabetically first. So how many y's am I going to have? Cubed. Good, because I have y times y squared. Okay, now can I just stop? No. I now have to simplify this, right? So breaking down each piece inside that radical. Okay, let's start with the cube root of 8. What is the cube root of 8? 2. I'm going to write the 2 out front because we know the 2's go in front. What is the cube root of x squared?
3/2.
Is it breakable? No, you can't break it. Rewind question?
Yeah. How'd you get 8x?
I multiplied the things on the inside together. So 2 times 4 is an 8, and then I have an x squared, and I have a y times y squared to make y cubed. Okay, so where were we? The cube root of x squared can't be broken because the squared is smaller than the cubed. What about the cube root of y cubed? Is y. Okay, so we're going to have 2xy out front, and the piece that stays inside is going to be just that x squared that was unbreakable. Okay. Everybody good there? Another one? Oh yeah, I got another one. I'll come back. You're still confused? It's fine. That's why you have Jaden sitting next to you, right? Okay. So number 6. This one is a little trickier. Okay. Do I need to go back to the last problem at all? Did everybody get it? Okay. All right, now, number 6 now has division, okay, with radicals. Okay, so I'm going to make basically the exact same statement I did first. Okay, when you're dividing, you divide things that are on the outside by each other, and you can divide things that are on the inside by each other only if they're the same kind of radical. So, can I divide these two? Why not? They're not the same radical. So I cannot say 64y over 64y is 1 and be done with it. Okay, so what I have to do is I have to break the top individually and break the bottom individually. Okay, so let's start with the top. What's the square root of 64? 8. What about the square root of y? Can't break it. Okay, on the bottom I have a cube root. So what is the cube root of 64? 4. And what about the cube root of y? The cube root of y, unbreakable. Okay, now what's my next step? Divide by 4, good. So I can reduce the outside piece. So would you all agree that's 2 square roots of y times the cube root of y? Or over the cube root of y. I said that wrong, but I wrote it right.
So why can't you do the 64? Why is it kind of like the same thing?
You can if they are the same root. So if these were both square roots, then you could. Or both cube roots. I don't know. Read the story problem and then you'll know.
Yeah, when you're a math teacher.
Depends. All right, so am I finished? Yeah, this is unsimplified because we have a radical in the bottom. You can never leave a radical in the bottom. It's unsimplified. So, here's the thing about this. This is a little tricky. Are you ready? Okay. What kind of root do I have in the bottom? Cube root. Cube root. So, what is the only way to eliminate a cube root? Y to the what? To the third, right? So I need to have it say the cube root of y cubed. Now right now, how many y's do I have in there? 1. So how many more do I need to get a y cubed? 2. So what am I going to multiply by? Y, the cube root of y squared. Okay, so I'm going to multiply the top and bottom by the cube root of y squared, okay, which essentially is just the value of 1, right? It's a very fancy looking one. So what do I have left on the top here? A whole bunch of, 2 square roots of y times the cube root of y squared. Now what's left on the bottom?
Why? Why did it get squared?
Because the only way for me to get rid of the cube root is to have y cubed, right? So what's y times y squared? Y cubed, right? So that's how we get the y cubed, and the cube root of y cubed is y. If I only multiply it by 1, I'd only have a y squared in the bottom. We good, or shall I keep going? Should we do one more? Okay, I see a few yeses. Let's do one more. I'll give you one with a division here. Okay, try this question number 5 on your own. We'll see if you can get it right. Simplify that. Mm-hmm. Okay, so make sure that you read the instructions right here. Okay, this problem is going to be easier if you write it as a rational exponent, so putting it into the exponential form, simplifying it and going back. Okay. Okay, so start by writing this in exponential form and simplifying it. Okay, are you ready? Okay, so on the top, what would the exponential form of that be? X to the 3/2, good. What's the bottom going to be? X to the 2/3. So what are we going to do with those two exponents? Subtract them. So what I need to know is, what is 3/2 minus 2/3? Okay, so I need a common denominator, which would be 6. So I'm going to have 9, 6 minus 4, 6. So that makes 5/6. So what is this equivalent to? X to the 5/6. Now if they wanted this to be in radical form, what would the radical form of this be? All right. Okay, so those two pieces are equivalent depending on which form they're asking for. Good there? I feel like we got this. Multiplying insides with multiplying. We got that. We got that. Okay, I think we're good.